In this video, we'll be working example 3 of section 11.3 notes. You've been looking at the difference between average velocity and instantaneous velocity. This example has both of those calculations. Example 3, the distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. A, find the average velocity of the object from 2 seconds to 4 seconds. Notice it's asking for average velocity. To find the average velocity, we're calculating the slope of a secant line, or what looks like a slope formula. Difference in y values divided by difference in x values. So we're going to calculate s of 4 minus s of 2, that's the difference in the function values, divided by difference in the x values, 4 minus 2. We just have to be careful with parentheses with our calculations. S of 4 is simply obtained by plugging 4 into the function called s everywhere we see a t. So that gives me s of 4. Then we're going to subtract. Now be careful here. I'm going to be subtracting more than one term, so I definitely want to use a set of parentheses. You have to intentionally put those in so you don't make a mistake. Now we're going to calculate s of 2. This time we're plugging 2 in for t everywhere we see a t. And I'm going to close parentheses. And the whole thing is divided by 4 minus 2, which we could evaluate to be 2. So working through here little by little, we have 2 times 4 squared, which is 16, and 2 times 16 is 32, minus 5 times 4, which is 20, plus 40. Again, be careful here. Let's evaluate what's in parentheses, and then we'll subtract that quantity. We have 2 times 4, which is 8, minus 5 times 2, which is 10, plus 40, all divided by 2. We have 32 minus 20. That gives us, 32 minus 20 gives us 12, and then 12 plus 40 gives us 52. Inside parentheses, we have 8 minus 10, which is negative 2, and negative 2 plus 40 is 38. So inside parentheses here we have 38. So we're going to subtract 38 and divide by 2. 52 minus 38 would be 14. And when we divide that by 2, we come up with 7. Okay, now let's consider the units. In the top of our fraction, we were calculating function values. The function values were distances in feet. In the bottom of the fraction, we were calculating time in seconds. So this is feet per second. Thus, the average velocity is 7 feet per second. Now let's move on from average velocity to instantaneous velocity. In this case, we're moving from finding the slope of a secant line to finding the slope of a tangent line. Here's the formula. We need to find the limit as h approaches 0 of s of 4 plus h minus s of 4 all divided by h. That's a big thing to calculate, so let's break it up into steps. First of all, let's find s of 4 plus h. So I'm going to be looking at my function, and everywhere I see a t in that function, I'm going to replace it with 4 plus h. So we end up with 2 times 4 plus h quantity squared minus 5 times 4 plus h plus 40. We need to be careful here to FOIL before we evaluate this multiplication, because that's the order of operations. So 4 plus h times 4 plus h, when we FOIL it out, is 16 plus 8h. Notice the outside terms are 4h, the inside terms are 4h. Those combine to give us a net middle term of 8h, and then h squared. We can distribute our negative 5 here to get negative 20 minus 5h plus 40. Next step, we can distribute our 2 into this first set of parentheses. We get 32 plus 16h plus 2h squared. Let's clean this up a little bit. If we combine like terms there, we get plus 20 and minus 5h. And then finally, combining like terms and putting it in descending order, we have our highest powered term, 2h squared. Then we have 16h minus 5h. That should give us plus 11h. And to finish off, we have 32 plus 20, which is plus 52. So that calculates the first half of our instantaneous velocity formula. Next, calculate S of 4. This part will be a little bit easier. To calculate S of 4, we're simply plugging 4 in for t everywhere we see a t. So we have 2 times 4 squared minus 5 times 4 plus 40. 2 times 16 is 32, minus 5 times 4, which is 20, plus 40. Again, we have 12 plus 40, or 52. Notice we did that up here before when we were calculating that first number. Now, let's put it all together. So here's our formula. We want to find the limit as h approaches 0, first of all, of what we came up with for S of 4 plus h. We got 2h squared plus 11h plus 52. Then we're going to subtract S of 4. We calculated 52 at that point. And then we divide the whole thing by h. When we simplify, we get the limit as h approaches 0 of 2h squared plus 11h divided by h. At this point in your problem, everything without an h should cancel out. If it doesn't, then something went wrong and you should look back over your algebra. Okay? Notice everything that's left in our result here does have an h, so I can factor an h out of the top, and then that would allow me to cancel that h in the denominator. Once I cancel that h, I have a limit that is defined. Notice there's no problem with a 0 in the denominator, so I can simply plug my target value in and evaluate. Therefore, the instantaneous velocity at t equals 4 is 11 feet per second. So we have the difference between average velocity. Make sure you know how to apply that formula. Slope of a secant line is what it looks like. And then we have the formula for instantaneous velocity. Please don't be discouraged by this problem. We're learning how to find a derivative by definition. Shortcuts for this problem are coming soon. So do your best, refine your algebra skills, and hang in there.